Hello and welcome to this IB Maths Intense session, part of Topic 3, Geometry and Trigonometry, working with triangles 3, and we are now going to be looking at how we can use the unit circle that we discussed in the previous video in a number of problems that we might be given with angles in degrees. And the previous video, maybe you found that complicated, made your head hurt, just understanding how it worked. So hopefully by giving some examples in this video, it will make things a little bit clearer. Just as a summary of what we were doing before, we saw that any angle between 0 and 90 degrees, which we could call theta, is actually part of a large family of angles that all share the same sine, cosine, and tan ratios. The only things that would be varying would be the whether the value was a negative or positive one, depending on where it was situated around that unit circle. So, for example, in the first quadrant, the A there tells us that all ratios, whether the sine, cosine, or tangent, have a positive value. In the second quadrant, marked S, for angles between 90 and 180 degrees, only the sine ratio is positive. In the third quadrant, angles between 180 and 270 degrees, only the tan ratio has a positive value. And in the final quadrant, 270 to 360 degrees, only the cosine ratio has a positive value. And of course, we can go around that circle many times. So the angles don't need to be between 0 and 360. We could have any angle. All we need to think about is how many times have we gone round to get back to a starting point of 0. And we can also have negative angles as well if we decide to go round the circle in the other direction. And to work out what that family of angles would be, well, let's do a simple example. Let's imagine that I had sine 20 degrees. I can build a family of angles up. Let's go in an anti-clockwise direction, look at the positive angles first. If I go, that's my angle in the first quadrant. In the second quadrant, the equivalent ratio would be an angle of 180 minus 20 degrees. So sine 160 is also part of the family. And in the third quadrant, this time I've gone to 180 degrees, and then I'm going to add my 20 degrees this time to get sine of 200 degrees. And in the fourth quadrant, I'm going to go all the way around. This time I'm going to calculate 360 minus my 20 degrees to get sine 340. Now, they're not all going to have exactly the same value because sometimes they're positive, sometimes they're negative. In the first quadrant, sine 20 is positive. So sine 160 will also be positive and they will be the same value. The third one, sine 200, is in the third quadrant, so it would be negative. So sine 20 would actually be equal to minus sine 200 because a minus would then make it plus again. And then similarly in the fourth quadrant, sine 340 would only be the same as sine 20 if we made it minus sine 340. And that family all share the same value. Now, if I wanted to, I could go around the circle in the other direction, and the equivalent angles to sine 20, well, I could go to sine of minus 20, going round this way this time, and then I would get to the next angle would be sine, well, it was 180 minus 20 is 160, so it would be sine of minus 160. You can see that the same values that we had above. If I keep going, I've got sine of minus 200, and in the fourth quadrant, going in that clockwise direction, I would have sine of minus 340. Now, which ones of these would have the same value as sine 20? Well, in that fourth quadrant, sine minus 20 is going to be negative. So sine 20 would have to be equal to minus sine of minus 20. And similarly, in the second quadrant, sine of minus 160, I'd have to make that negative for it to have the same value as sine 20. Sine of minus 200 is in the second quadrant, and so we'll have the same value as sine 20. It's positive in both cases. And similarly, sine of minus 340 is in the first quadrant, and so it also is positive. So that family of values there, all of them share the same value. And we could play this game all day because we can keep going round in multiples of 360 to find another value. So I know that sine 220, if I went round another 360 degrees and ended up at sine 380, that would be one whole turn plus another 20 degrees. That would give the same value as sine 20, and so on. And that's going to be very, very useful because we are frequently going to be asked to find multiple solutions when we're dealing with angles questions. So here's a good example. Let's just check that we've got the idea. Which angles x share the same value as sine 50, where the angle that we're looking for lies between minus 360 and 360 degrees. So we know that we've got sine 50. Our value for theta here is 50 because theta needs to be our angle that sits between 0 and 90 degrees. And the thing to look at here is in which quadrants would angle x share exactly the same value as sine 50? Well, sine 50 is positive. It's in the first quadrant. And only in the second quadrant here do we return a positive value for sine. So we're looking for a solution that sits in that second quadrant. Well, where our angle between 0 and 90 degrees is 50 degrees, in the second quadrant, we'd be looking at sine 180 minus 50, which is sine 130. If I keep going into quadrant 3 and quadrant 4, so angles between 180 and 270, and between 270 and 360, they will not return the same value as sine 50 because the sine ratio is negative in both of those quadrants. So there is not a correct solution there. But I'm also being asked for angles that are negative. And so again, I'm looking in the first and the second quadrants, but I'm looking at what the negative angle is. So going round now in a clockwise direction, my angle would be 180 plus my 50 is 230, but it's an angle of minus 230 because I've gone in the other direction. So an equivalent angle would be minus 230. So sine 50 is the same as sine minus 230. And if I keep going all the way around to get back into the first quadrant, I'm going to have an angle there that's heading towards sine minus 360, but less the 50 degrees that my value of theta is. So I would have sine of minus 310 because there's still another 50 degrees to go to get to 360. So those are the family of four angles between minus 360 and 360, which give the same value as sine 50. Hopefully, the more we practice this, the more second nature it becomes. Let's have a look at for cosine. This time we're told that which angles share the same value as cos 70. So we'll write that down. That's our first solution, cos 70. We need to ask, first of all, where would we go looking for angles that have the same value as cos 70? So obviously in the first quadrant, but cos 70 is positive, and cos is only positive again in the fourth quadrant that I've marked there. So those are the two places I'm going to look. So going in a positive direction, so going in an anti-clockwise direction, I don't get another value that's the same as cos 70 until I'm in the fourth quadrant. And that's going to be 70 degrees short of 360. 360 minus 70 is 290. So cosine of 290 will give the same value. Now if I decide to go in the other direction, so instead of going in an anti-clockwise direction, I'm going to go for negative angles. I'm going to go in an anti-clockwise direction. Sorry, a clockwise direction. Then I know it's still in those two quadrants. The first angle will be in this fourth quadrant and will simply be cosine of minus 70 because I've gone round as far as that red line marking the angle theta in the fourth quadrant. So minus 70. And then I'm going to go all the way around until I get to here. And that's going to be, it's all very symmetrical, cosine of minus 290. It's in the first quadrant. It's all the way around, just 70 degrees short of 360, or minus 360 in this case. So cosine minus 290. There we've got four angles that share the same value as cos 70. So let's have a quick look at the tan ratio. This time, to make things a bit more tricky, I've said which share the same value as tan 100. So in this case, I'm looking at the circle and seeing that tan 100 isn't in the first quadrant. So it's in the second quadrant. And in the second quadrant, my angle, the tan ratio will give a negative value. So I know that I must be looking in the second quadrant, and in this case, the fourth quadrant. These are the two quadrants where tan gives a negative value. And the next thing I need to look at is, what's the value of theta then? If I've got an angle for tan 100, which is the value of theta in the first quadrant that it came from? Well, it's going to be 180 minus my 100 degrees gives 80 degrees. So I know that in the first quadrant, theta was equal to 80 degrees. So we can just make a little note of that, 80 degrees. And that's why in the second quadrant, I ended up with a result of 100 degrees. So into that fourth quadrant, the equivalent angle to tan 100 would be tan of 360 minus 80 degrees, which is tan of 280 degrees. And now, of course, that was only looking at angles in a positive direction, going in anti-clockwise direction. If I go in the anti-clockwise direction, I'm going to end up with tan, and this time it's going to be minus 80, because my angle theta is 80 here. So I'm going the other direction, and then I'm going to end up with tan of minus 260. It's going to be 180 plus 80 is 260, but it's in a negative direction. And there's the four angles that together share the same value as tan 100. So you can see that you will get very, very good at being able to calculate in your head. The angle's 100, so the angle that it came from, was derived from, is 180 minus 100 is 80. So the family of angles were 80 and 100, and 180 plus 80, 260, and 360 minus 80, which is 280. But those are the four that share the same value because they're in the two quadrants that return a negative value. What other things might we get asked? This time I'm told that sine theta equals 0.5. Find all the possible solutions where theta sits between minus 360 and 360. Now your calculator is a brilliant machine, but it doesn't know every possible solution, because if you said inverse sine of 0.5, it couldn't give you a list of every possible solution because there's an infinite number of solutions. It will only give you the one solution that it can. And for sine, the calculator will only ever give you values for angles that are between 0 and 90 degrees where the value is positive, and values between 0 and minus 90 where the value of the ratio is negative. It's called the principal value. And based on that principal value, we can then work out all the other possible solutions. Now, if I look on my calculator and say inverse sine of 0.5, it'll give me a principal value of 30 degrees. So I know that the first solution is 30 degrees. That's what my calculator's told me. But I'm looking at all the other places on that diagram between minus 360 and 360 where the ratio could be positive, because 0.5 is positive. And it would be in the first quadrant and in the second. Those are the two places where the result could be 0.5. So I look for the corresponding angle, this time going in positive angle, and I've got 30 degrees, and I would have an equivalent angle of 180 minus 30, which is 150 degrees. So that would also give me a result of 0.5. None of the other angles between 0 and 360 would give me the same value, because in the third and fourth quadrants they are negative, the values of sine. If I go in the other direction, I need to go all the way around in the negative direction into that second quadrant, and I would end up with an angle of minus 180 plus my 30 degrees would be minus 210 degrees. And into the fourth quadrant, it's going to be 30 degrees short of 360, so it's going to be minus 330 degrees. So those are my four possible solutions for theta that would give a result of 0.5. So if I was to go on my calculator now, sine of minus 210 degrees, that would also give a result of 0.5, just like sine 30 would give a result of 0.5. In this example, let's have a look at the cosine ratio just to round things off. Cosine theta equals minus 0.5. Find all the possible solutions. Now, it's a negative result here, so again, I'm just going to highlight a negative result for cosine must come from either the second quadrant or the third quadrant. Those are the two places where cosine is negative. Now, the cosine on the calculator, positive results will all be angles between 0 and 90 degrees, and negative results will come from the second quadrant, will be between 90 and 180 degrees. And sure enough, if you were to look on your calculator and do inverse cosine of minus 0.5, it would tell you the principal value for this angle is 120 degrees. So that's one of our solutions. The next thing we need to do is to say, well, if the angle is 120 degrees, my value for theta, the value between 0 and 90 that's driving this, must be 180 minus 120 is 60 degrees. So, into my third quadrant, which is also negative for cosine, then another solution would be 180 plus 60 is 240 degrees. That will also give me the same result. Now, if I go for negative results, again, I'm looking in that second and third quadrant here. I'm going to go minus, and I'm going to go minus, but I'm going to go 60 degrees short of 180. It's going to be minus 120 degrees. And then I'm going to go a further 60 degrees on from 180 to get minus 240. Notice for the cosine, the results there are symmetrical. You have two solutions that are positive, you will have the equivalent results for the negative angles. That's always the case, but only with cosine. So there's our four possible solutions for theta, where cosine theta equals minus 0.5. Now, you won't always be asked to find solutions between minus 360 and 360. Always look at the range of solutions that you're being asked for. In this final example, just for good measure, let's look at tan theta equals minus 1. And we want all the possible solutions, but this time only positive angles, but between 0 and this time 720. So again, looking at the graph, where tan is negative in the second quadrant here, and the fourth quadrant here. For the tan ratio, when I do inverse tan of an angle, for positive values, it'll give a value in the first quadrant. And for negative values, it won't give me angles between 90 and 180 degrees. It'll give me negative angles, so between 0 and minus 90. That's how the calculator behaves. So in this case, inverse tan of minus 1 shows me an angle of minus 45. So I know that minus 45 tells me that the angle theta must have been 45. That's been driving this solution. So let's have a look in the other places where we would have got a result of minus 1. So let's do the negative ones first, since we were going in that direction, this direction. But minus 45, and we're going to go into the second quadrant, where we're going to have an angle of 180 plus 45 is 225, but it's going to be negative. So those are my two negative solutions to give an answer of minus 1. And then going in the other direction, going in the positive angle direction, I'm going to go into the second quadrant, and I'm going to have an angle of 180 minus 45, which is 135. And I'm going to keep going round now into the fourth quadrant, where tan is, again, negative, and I'm going to be 45 degrees short of 360, which is 315 degrees. So I've got 4 solutions there that all would give a value of -1. However, the question didn't ask for negative solutions. So actually, the first 2 there, -45 and -225, I'm not going to list those as part of my solution because I wasn't asked for negative angles. And now I've got to go around again because I want angles between 360 and 720. So I need to think about these solutions going anti-clockwise. Once I've been round a full turn of 360, to go for a solution of -1, well, I'm going to go another 135 degrees on from 360. So my first solution, I'm going to add 360 degrees to that, and I'm going to get 495 as a solution. And that angle there of 315, I'm going to go another 360 degrees round to get to that point again. So I'm going to end up with 675 degrees. So those are my 4 solutions there that would give a value of -1 for tan theta. So be careful with that in the question. It will give you a range of values in which your solution must lie. Make sure you stick to that. It doesn't do any harm, like I did, to work out all the possibilities, but make sure you scrub out the ones that aren't relevant to your solution. So we've done a number of examples there of working with that unit circle to help us find a number of possible solutions. And you're going to need to be able to do that because your calculator can only give you one principal value when you're working with inverse tan, and you will need to find all the other possible solutions that fit using that logic. I hope you found that useful. Thank you for watching. Don't forget to like this video, subscribe to my YouTube channel, IB Maths Intense, and of course tell your friends I'm here, or drop me an email at ibmathsintense@gmail.com with any suggestions, any errors you found, any things that weren't clear, things you'd like me to do. In the meantime, work on that unit circle. Make sure you understand and learn how to use that. Enjoy your maths and take care.